Many parents ask us, do I look for coding or robotics program for my child? What is the difference between them? Now our answer to that is very simple. These two are actually the same under the umbrella of computer science and ICT. Hi everyone, my name is Jonathan Ho. I'm the founder and CEO of Graphite Academy, and we are a coding school for kids. So we started the company because we realized there was a disconnect with what the parents wanted versus what the industry was providing.
Hi, my name is Rena. I'm the co-founder and CEO of Graphite Academy. At Graphite Academy, our mission is to provide students with quality coding education to prepare them for their tertiary education in computer science. Learning from us should provide students with a head start in their computer science education.
To date, Graphite Academy has taught over 120 schools in Singapore, both primary and secondary school, on the topic of coding, programming and robotics. And because of that, we have impacted over 10,000 students in Singapore. What a coding school does is we introduce students to many concepts that are very relevant to our daily lives. Things such as app development, web development, robotics, hardware, AI, AR and VR are all prevalent in our daily lives, but most of us don't know how these things work, how these things function.
Coding is a compulsory enrichment subject in MOE schools starting from primary 4. This is important when students move on to tertiary education, as it is a mandatory module for many diploma and degree programs.
Our students also learn skills such as problem solving, critical thinking, and even learn how to appreciate the mathematics they've learned in school and apply them in real and relevant concepts.
My intention is just to give him the exposure, and if possible, if he really likes it, is to support him all the way until P6.
Our students have also won awards from competitions such as First Lego League, National Primary Games Creation Competition, National Robotics Competition, and many other competitions as well. And the most recent one was the Coding Olympics 2022, in which we organised it with Science Centre, and our student actually achieved second place out of 800 students in the entire Singapore. We are also a member of the Computer Science Teachers Association of Singapore, which is actually recognised by multiple industry tech titans. Companies like Facebook, Microsoft, Google, Amazon, even Rolls-Royce recognize this as the gold standard of children's education for computer science.
Flying Cape is Singapore's largest online booking and advisory platform for tuition and enrichment classes for children. On the platform, parents can first discover your child's strengths, interests and learning profiles through validated assessments that we offer. For children 6 to 12 years old, our gamified assessment allows your child to try out a series of challenges while navigating through 8 different islands, each representing a different intelligence. While your child is having fun, parents receive a diagnostic report that provides insights into their unique competencies and learning styles. Based on your child's unique learning profiles, we offer personalized recommendations that help parents customize the best education programs and classes. We also have a best price guarantee promise to ensure that you will always get the best prices with us. Choose from the widest range of education options on the platform, such as trial classes, workshops, holiday programs, learning kits, and more. Earn reward points when you make a booking through us and redeem vouchers and gifts. Always on the lookout for the best education deal? Join our group buy under Edu Hunt, which allows you to snag the best savings on workshops or classes that you're interested in. Simply place a reservation for the class that you are interested in and help spread the word during the time sale period. The more people joining in, the greater the price savings for everyone. Join our community of happy learners now. Check us out at www.flyingcape.com.sg.
Is your child ready to take their coding skills to the next level? Introducing Elite Coder, the groundbreaking certification program brought to you by Singapore Science Centre Global and Mango's Teams in partnership with Flying Cape. The program is designed to map a student's mastery of coding at 3 different levels: basic, intermediate, and advanced. Here's why your child should sign up. Elite Coder enhances their coding portfolio, giving them a distinct advantage. Elite Coder evaluates your child's competencies based on the CSTA K-12 Computer Science Standards. Upon completing each assessment level, students will receive a scorecard indicating their level of proficiency. They will also receive an e-certification by Singapore Science Centre Global, recognizing their achievement. But how do students prepare for the assessment? Our authorized training partners will ensure that students receive the best guidance. In the training workshops, Our experienced trainers will cover elite coder requirements and expectations at each level. They will deep dive into the syllabus and guide students through code writing lessons aiming at solving real-world challenges. So, what are you waiting for? Give your child the opportunity to excel in coding. Find out more at elitecoder.flyingcape.com.sg.
Very careful. There's a python around here. I'm sure it's around here somewhere. Uh-oh! You're tickling me! Python is the name for a coding language, and it's not as scary as it looks. It's perfect for kids. It looks pretty, doesn't it? That's because Python is really good for code readability. That means that it's easy to look at and understand. Behind all that simple stuff are some neat mechanics, like libraries and functions. A function is like a block of code. That means it's only used when it's asked to do something. Imagine a machine that uses functions to make smoothies. The function for peeling the bananas only works when it's time to peel a banana. And that's the same for the other part. Banana. But that's not all it can do. It includes tools for data analysis, machine learning, and software development. That's why lots of your favorite apps use Python. It's a great way to learn coding, especially with me. But it's also used in devices and jobs and amazing careers. Who knows where Python will take you? If you want to go on a Python journey with me, then check out CodeMonkey Python coding courses to start learning now. Please like this video, share with your friends, and don't forget to subscribe to our channel. Thank you for watching. See you soon!
Right, it's 4 o'clock right now. So hi everyone, welcome to the Code Monkey Olympics, right? For the second day. Again, my name is Kelvin, and hello, right? I hope you enjoyed yesterday. So today we'll carry on where we left off from yesterday, right? So I saw in the chat what some of you asking what we are doing today. We are doing variables and arrays today. Okay, right. Okay, I apologize for my birds yesterday. They were making a lot of noise, so it's distracting. So today I'm in another room. Okay, so now with this, let us start with let me project my slides so we can start with I can start with the explanation, right? So give me a minute. Let me put up my slides. Okay, so so you can see the whole thing. Okay, this is my slides, right? So this is day one, so I'll skip the day ones. This day two. Sorry. Okay, so this is day one. So I'll just skip day one, right? Okay, who didn't manage to finish 30 all the 30 challenges? Okay, now if you didn't finish the 30, it's better to try to finish it so that you can continue on, because if you don't finish 30, they will not let you go to 31. Okay, and if you have any questions, again, like same as yesterday, please type in the chat so that I can assist you all, right? So today is day two. Sorry. Okay. Now, okay. So your login information is here. So again, same as yesterday. If you cannot log in into your competition account, please ask whoever signed you up, maybe your parents or your teacher, or if you sign up yourself, so it should be through your parents as well. So ask them for the details, right? Okay, so there's only two competition categories, which is A and B. Primary 3 and Primary 4 students will be at Cat A, and Primary 5 and 6 will be Cat B. Now, Primary 2 students, there's no category of competition for you. So maybe try again next year. Join us again next year if you want to compete, right? Okay, so what we'll be doing today is this. Day two. Oh, sorry, this is the wrong slide. Okay, never mind. Day two, we'll be doing 31 to 60 challenges. So again, I will go through the basics with you all and the theory before I let you all try the competition, try the exercises, right? So again, if you cannot hear me, let me know, and follow instructions that that I give. If it's a 10 minutes break, come back in 10 minutes, right? Any questions you need to ask in the chat room. Please do not flood the room, and please keep your messages polite, right? Okay, now hands-on challenges. That means I will give you all the challenges later, and you'll do it on your during the breaks. If you're unable to finish or you have issues with the questions or the challenges, you type in the chat. Let me know. I will assist you all. All right. Okay. Now, like I said earlier, challenges will be allocated specific time slots. So maybe 10 minutes, maybe 15 minutes for you to try. Right. Today will be more complex, so I'll go a bit slower because variables and arrays are more complex than yesterday's. Okay. Now, for competition, sorry, my dates are wrong again. For the 3rd of August, which is category A, the competition will start at 9. The opening hours will start at 9. So you can log in at 9 o'clock and start the competition. You'll be given 1 hour. Now, the last login you can do is at 4:59. But please don't try and log in at 4:59, because if there's a lag in time, if you're lagging, then you might not be able to log in time and you'll be cut off from the competition. Right? Same as the day 6, which is 4th August. 4th August, same thing. You can log in. You can start logging in at 9 o'clock, but try not to log in at 4:59. Right? Try to log in about 3:40, 3:59, 4 o'clock, somewhere there, right? I know some of you like to game the system. I used to do this as well, but if you like I said, if you experience a lag, then you'll be cut off from the competition, right? Okay, so for today, again, logins are the same. If you cannot log in, please ask the person who signed you up for the login details. Okay, right. So today we'll continue with our coding adventure. We'll start at 31. Now, before we start, you must know what's a variable, right? So I'll give the theory of variable. A variable, as you can see in the slide, it's a storage for information. But you must remember this. The variable can only store one information. Why do I say that you can only store one? Or why should you remember this? Because later on, when you encounter arrays are different from variables. Right? I explain the arrays later when we encounter arrays. So for variables, think of it as a box that you can put any name you want. Right? So for me, I'll put test because that's my go-to. Yeah. So I can put any value in it. I can put my test to be value, I don't know, 1, or my chat suggests, I cannot read this. I don't know how many millions it is or how many zillions it is, right? So some of you like to put 1,000,000. So for now, the box test, if I put 1,000,000 in it, will have the number 1,000,000. Will have the value of 1,000,000, right? So I can use this value anywhere in my code. Can? So later when you do it, you only use one alphabet to represent a variable. So you don't have to use test, but test when in the future you want to use it. Can? Right. So with this said, later I'll show you all what are arrays. So don't panic when you see arrays, right? So I'll walk you through it. I'll walk you through the variable first. So let me start up my CodeMonkey. And okay, if you can see, this is challenge 31, right? So I'm already at variable value. So challenge 31 is the opening of variables. Right. So first thing they teach you here is that you can use an alphabet to represent a number or to give the alphabet a number. Right. So for this, I'll put the default is X. So in order to make a variable, you must have an alphabet or object, or yeah, for this we'll use alphabet. You must put an equal, because if you don't put an equal, you cannot add a value to the variable. So for here, we'll put X equals 10. So my value for X is 10, right? So remember, it can only store one value. So for now, it's 10. If I put 11, then it'll become 11, right? I can change the value, but it can only store one value. So if I put 1, then X becomes 1. I cannot put X 12 or 13. It doesn't work this way, right? It will get confused. So remember, variable can only store one value, right? So for this, we'll represent the value with an alphabet. So we have to see how far it is, the banana and the monkey. So use the ruler, click on the, okay, so for this, it's 20. So my X will be equals 20, right? So next one I type is step X. This will make the monkey move 20 steps, right? So like that. Okay. Yeah. Sorry, my volume was a bit loud. Sorry. Let me replay this. Let me reduce my volume first. Okay, so yeah. So remember, you can use a variable and give it a value, right? Yay. Okay, so next, it gets more complicated. If you can remember what we did yesterday, we did a loop, right? You can use a variable to represent the number of loops as well. So for example, I do want 4 times. I can just put X and it will run 5 times. Right? Because my value of X is 5. Now, if you notice, some of you are sharper or more attentive. If you notice, when I press the run, when I have a variable, when I press the run, a small window will pop up here to indicate the value of my variable. So for now, my variable is 5, right? If I change it to 6, my variable will show as 6. There. So you have a small window to tell you, because later on, when you have more than one variable, it's easier for you to keep track. The window helps you to keep track of which variable is running, right? So for now, I need you all to do coding adventure 31 and until let's see, until 37, right? Because 37 onwards, it's an array, it's something else. So I'll stop here at 37 first. We'll stop at 37. Then I'll run through 37 onwards with you, right? So take like 10 minutes to do this, and I'll see you all in 10 minutes. Right? And if you have any questions,
Oh, hi. Are you wondering what I'm doing? I'll show you. This is quite neat, isn't it? And I made it myself. And you can do it too with coding. What's coding? Well, have you ever wondered how computers do the things they do? Like play movies or show pictures or make music? How does it know what to do? That's what I wanted to know too. Computers know what to do because of coding. Think of it like a recipe book for when you want to make your favorite food. When the computer is turned on, it needs instructions. And when you ask it to do something, like use Netflix or YouTube or anything, it's like giving it a recipe for how to do it. But instead of ingredients and cooking, it uses something called a programming language. To us, a page of code looks like a page with numbers. But to a computer, it's in a language it can understand. And there are different computer languages in the same way that there are different human languages. We have English and French and German, and they have things called C++ or Python or Java. So if you can understand English, you can follow a cooking recipe written in English. But if you don't understand French, then you won't know what to do with the French recipe. Anyone can learn to program, and some languages are easier than others. If you work hard at it, you can get a computer to do whatever you want. That's how they make video games. That's how they make computer programs like drawing software. And it's even how they make websites like YouTube and TikTok. Nowadays, almost everything uses a computer in one way or another. Can you think of how many things in your house use a computer? Smartphones and devices are little computers. TVs also have computers in them now. Even things like microwaves and calculators have teeny tiny computers on them. So how do we get all these computers to work together if they use different languages and do different things? It's kind of like human languages. All the different languages in the world might have different words and sounds, and even a different alphabet. But they all have a few things in common. They all use letters to make words, and the words go together to make sentences. And sometimes, even if we don't know exactly what someone is saying, we can understand what they mean by how they say it. It's a bit like that for computers. It's always better to speak to a computer in its own language. Speaking to it in a different language might lead to mistakes. So maybe you have your own idea for an app, or video game, or computer program, or maybe something so futuristic and advanced that only you can think of it. Well, you can make it happen. There are lots of smaller, easy computer languages to learn to help you understand the basics of coding. And once you master the basics, you can move on to more sophisticated and challenging languages to really make things take off. When you finish a program, please let me know. You can tell me about it in the comments. Also, please like this video to
All right, welcome back. Right, I'm experiencing a bit of lag, so my timing is a bit off. Right, I've been looking at your chats and I've seen what you need help with. So I will start with 34 first, right? So let me share my slide, my screen. Sorry. Okay. Now, oops, sorry, wrong one. This one. Okay, so I'll go to 34. Then I'll walk you through it, right? So at 34, this is what you should be doing. Okay, so there are three variables here, right? So t will be equals the number of times you need to repeat it, right? So for here, t is equals 1, which will not work because it's a triangle. So you got to count how many times you want it to repeat, right? So x is the number of steps. So x is not 10. You have to use the ruler to measure the distance from one end to another end, right? And d, turn d means it'll turn the degrees. So I'll use this. And is it 120 degrees or is it 60 degrees, right? So for this, you need to measure. So we'll do it step by step. First, I will move the monkey one straight line down first. So then I can test the turning, right? So I'll change this to 20, right? Okay, so 120 is correct. So the turning for 120 is correct. So I'll leave D I'll leave alone. So I've changed X because this is the number of steps I'm supposed to move, right? So the next one I need to change is T. So how many times or what value will represent T or will T represent, sorry. So for T, it's like 1, 2, and 3. So I'll change this to 3 times. And for now, so 3 times, it'll step X, it'll step 20, and it'll turn 120 degrees. It'll repeat that 3 times, right? So for this, it's like that. Okay, this is how you do it. Challenging, yes, because it's getting more and more complicated. Right? It's getting more and more harder and harder. But it's not that difficult. So this is for 20. This is for 34. So which is the next one do you all need help with? The 40 plus we'll do later, right? For now, we'll stick at 20. We'll stick at 37 first, or 36. Okay, sure. I'll go to 36. Okay, so in this one, you need to define your own variable, right? So you want the turtle to step forward and you want the monkey to move, right? So how are you going to do this? They already give you a variable here, but you need to define the value of the variable. So for this, I will measure the turtle to the bridge, which is like that. So about 15, right? So my variable will be x equals 15. Then I'll run this and try it because every one of them uses the same value, right? They are using x, so you need to figure out how much x is. So if I give it 15, every one of this x will become 15, right? So if I run it, okay, so it works, right? So again, for this, you must define your value. So the value they give, the variable they give is x. So you put x, you give it a 15, you measure up your value and you give it the value, right? Remember, this number is represented by x or the variable, right? Okay, any other issues with this? No? If no issues, then I'll move on to 37, which I ask you all to stop at, because this is a different thing altogether. Okay, at 37, you're introduced to this. Let's just say boo, right? For this, you're trying to scare the rat to let go of the banana, because in the later stages, you see the rat will be moving left and right or up and down across the stage. So you got to stop the rat before you can get the banana, right? So for this, if we press say boo, the rat will run away. But how are you going to get the banana? So just use a simple step and measure the distance from the monkey to the banana. So right now it's 15. So for this stage, the banana is right in front of you. But for the later stages, it depends on where the rat is, and you got to add more code for it in order to get the banana. Right. So for this, step 15, boo, scare away the mouse, the rat, and then move forward. Okay. For this, again, you can type anything other than boo, but please, again, keep it polite. Please don't be vulgar, right? Or anything like that, right? You can type anything you want here, but remember, please keep it polite, right? Okay, now for 38, this will be a live test. So you need to ask it to stop, and you need to stop the rat and get to the banana, right? So what we do is you figure it out later. So for this, I need you all to work until, let's say 46, is it? Let me see where the arrays are. Okay, I need you all to work until, okay, stop at 45, because the next thing, at 46, I'll teach you a new concept regarding variables, right? So for this, take another 10 minutes to figure out how to do this, and I'll see you all in 10 minutes. Please stop at 45. Oh, 36, hang on. Okay, 36. I didn't see it, sorry, because I'm on another screen. Right, 36. Okay, 36. Again, it's a repeat. Remember, you can have more than one variable, right? So for this, what you have here is x equals 15, right? So it's just step 15 minus 15. Now, you got to ask the turtle to move as well. So you got to measure the turtle distance from one banana to another banana, right? So from here, I'll use the ruler. I'll measure here to here. So it's about 8, right? So now, sorry. So now, I'll just make here, I'll just do this. Turtle step 8, right? Now, how many bananas are there? There are 4. So my times cannot be 1. It must be 4 times, right? You can make a second variable, or, okay, I'll make a second variable then. Y equals 8, because I want the turtle to step. So turtle step, I don't put 8, I'll put Y, right? So run it. Okay, so it's looped, and you can use variables to do this as well, right? You can opt to use variables, or you don't use variables. But variables makes it easier so that you don't have to keep typing the same number. You just use the variable to represent the number. Okay? Is it good? Any others for now? Okay, now, okay, so take 10 minutes to do from, which is the one I wanted? From 37 to 45. Okay, yeah, please stop at 45, because if you carry on, you might not know what you're doing, right? And you get stuck. So I'll walk you through it. Then after that, you can continue until 50, right? So take 10 minutes, do until from 37 to 45. Okay, then if you, too short time, actually, if you know what you're doing, 10 minutes is a lot of time. Okay, so I will come and help you later. And if you have any issues again, please type it out in chat, I will come back and help you, right? So try on your own first. Can? Right. 10 minutes, try on your own. Then after that, I will come back and help you. 36, wait, 36 again? Okay. I just saw your chat. Give me a minute. Yeah. Okay, 36 again. Okay, so 36, you have two options. Okay. You can don't use a variable. You can don't use a second variable, or you can use a second variable. It's up to you, right? I can put turtle step because my previous one was 8, so I know it's 8. I just change the number of times. You can do this. Okay, you have an option to do this, or you have an option to give it a variable. So y equals 8. Why 8 is because I measured earlier using the ruler, the turtle to the second banana, or actually more the monkey to the second banana, right? So it's 8. So my y will be equals 8. So if I put y equals 8, if I use a variable here, I will remove this 8 and I'll just put y. I'll just use the variable to represent the number. Can? Can? Okay, so if there is no more questions for now, please take 10 minutes, do from 37 to 45. And if you have any questions, just type it in chat. I will explain it to you again. Right? Please, if you don't know what you're doing, or if it's the first time, please stop at 45. If you don't understand variables, please stop at 45. Because after 45, it's an add-on. It'll get more, if you don't understand variables, it gets more complicated. Right? So I'll walk you through it, then it's easier for you to do. Okay, so I'll see you all in 10 minutes. Please do from 37 to 45. Right?
Oh, hi. Are you wondering what I'm doing? I'll show you. This is quite neat, isn't it? And I made it myself. And you can do it too with coding. What's coding? Well, have you ever wondered how computers do the things they do? Like play movies or show pictures or make music? How does it know what to do? That's what I wanted to know too. Computers know what to do because of coding. Think of it like a recipe book for when you want to make your favorite food. When the computer is turned on, it needs instructions. And when you ask it to do something, like use Netflix or YouTube or anything, it's like giving it a recipe for how to do it. But instead of ingredients and cooking, it uses something called a programming language. To us, a page of code looks like a page with numbers. But to a computer, it's in a language it can understand. And there are different computer languages in the same way that there are different human languages. We have English and French and German, and they have things called C++ or Python or Java. So if you can understand English, you can follow a cooking recipe written in English. But if you don't understand French, then you won't know what to do with the French recipe. Anyone can learn to program, and some languages are easier than others. If you work hard at it, you can get a computer to do whatever you want. That's how they make video games. That's how they make computer programs like drawing software. And it's even how they make websites like YouTube and TikTok. Nowadays, almost everything uses a computer in one way or another. Can you think of how many things in your house use a computer? Smartphones and devices are little computers. TVs also have computers in them now. Even things like microwaves and calculators have teeny tiny computers on them. So how do we get all these computers to work together if they use different languages and do different things? It's kind of like human languages. All the different languages in the world might have different words and sounds, and even a different alphabet. But they all have a few things in common. They all use letters to make words, and the words go together to make sentences. And sometimes, even if we don't know exactly what someone is saying, we can understand what they mean by how they say it. It's a bit like that for computers. It's always better to speak to a computer in its own language. Speaking to it in a different language might lead to mistakes. So maybe you have your own idea for an app, or video game, or computer program, or maybe something so futuristic and advanced that only you can think of it. Well, you can make it happen. There are lots of smaller, easy computer languages to learn to help you understand the basics of coding. And once you master the basics, you can move on to more sophisticated and challenging languages to really make things take off. When you finish a program, please let me know. You can tell me about it in the comments. Also, please like this video to
Okay, hi, welcome back from your break. Now, I read in the chat, somebody needs 38 or something like that, or 41. 38, 39, 40, 41, right? Okay, so now I'll start with 38 first, right? I'm lagging, so I hope you don't mind. Okay, let me go to Code Monkey and I'll show you 38. Okay, so 38, we'll start with the say, which is going to confuse you, right? So for this, we'll just say x will be equals 20, so it's fine. But like I mentioned earlier, when you say anything or when you scare the rat will just drop whichever position. So most of us will try to time it so that it goes straight, but that's not how it's done. So for this, you need to measure the distance from, let's say, okay, 20 will be fine. Okay. So step 20, what do I need to do to face the banana? Right? I need to use turn to and banana. But is this correct? Is this step correct? Okay, the step is wrong. So what I need to do is place turn to banana first, right? So no matter where the rat drops the banana now, I can reach it because I'm facing it, right? So this is how it goes. There, right? So my monkey will face the banana and I'll walk the steps to the banana. Can? Simple? Okay, this one is not that difficult, but when I first started, it also stumped me, right? So you need to think. Need to think a bit. Normally for coding, I will use the 5W1H principle. So who, what, where, why, when, and how. So you break it down, use these 5 principles or use these 6 principles to break it down on how you're going to code or where your code goes, right? So next one I'll go to is 39. Okay, for this, there's no need for you to say anything because there's no rats for you, right? So X step distance to turtle. This is confusing for you. This will confuse you, but what it does here is it will just step to the turtle, right? So what you need to do is not step distance to turtle. You want it to go to banana. So what you do is change this to banana, right? Now step distance to is a function that that removes the need to put a number. So the code will automatically calculate the number for you, right? But you must have the variable first. So if my x is step distance to banana, it'll just step right next to the banana, right? This is how it happens. And it'll tell you why do we have a say is so that in programs where you don't have a calculator, where you cannot calculate the distance, using the say x will show you the distance from the monkey to the banana, right? So again, excuse me. Okay, so if you don't know the value, you can use a variable to make it come out, right? Yeah, I only get 2 stars. Okay, so if I want, okay, step distance to the banana, step x, because I have a say. So I don't need to use the say. Say is just for me to see the distance, that's all, right? So if I run this, that's it. I got 3 stars. Okay, this is for 39. 40? Okay. Okay. This one, you have a variable. The variable is given. So the variable is total distance to banana. So the turtle will travel to the banana. What you don't have is the code for the to command the turtle to move to the banana, right? So instead of step 2 here, I'll just leave a space there. I'll just move. I'll use this turtle distance. Oh wait. Oh, sorry, not distance. Turtle step X, right? Because this will make the turtle go to the banana, right? So run it, and then the monkey will just move forward, right? So this is confusing because you would think, most of us would think that X turtle distance to banana is a code by itself. This is a variable, right? This is not the actual code. So you need to ask the turtle to step first. If you don't ask the turtle to step, if you're not using this variable, then the turtle won't move, right? Okay, next. I saw 41. Yeah, 41. Okay. Okay, so this is challenging, right? So what we do is the turtle will step to the bush and it'll step away from the bush and it'll turn away. Now, what you need is for the turtle to step to the monkey, not to bush, right? So you need to change bush to monkey. So if I do this, oh, sorry, is it bush? Where's the bush? It's supposed to turn to bush. Okay, never mind. Okay, so what you need to do is define to the monkey. So we change this. Or the island, we put monkey. Nope. Okay, once you have this, once you manage to get the turtle to the monkey, then when the turtle turn, now you need it to step distance to banana, right? So sorry, I keep using step. Okay. Okay. So okay, right now I know my mistake. The distance to the monkey is the same distance to banana, right? So the turtle will just move forward, get the monkey, turn, and come straight down, right? So it looks like this. Right? Okay. So we're using the D to represent the distance from the turtle to the monkey and the turtle to the banana. Okay. It's a bit challenging, but yeah. Which one? 43? Yeah, 43 first then. Okay. Okay. This one, the monkey needs to turn to the bridge first, right? The first line is wrong, which says turn to monkey, turn to banana. So you need to use this, need to turn to bridge. Then you need to move to the bridge. So, okay. Then turn to banana and step distance to banana, right? So you need to put in these two codes first. The monkey cannot go direct to the banana. It needs to go to the bridge, then from the bridge go to the banana. Right? It's a repeat of what we did yesterday. It's just slightly more complicated now, more challenging. Okay, anything at 40 plus. Okay, I saw 45, so let's try 45. Okay, so for this, it's the same thing, same as the previous one, 43, right? This one you need to scare the rat first, then you need to ask it to go to the bridge, then to the banana, right? So first one, I will say, hello. Let's go. Okay, fine. Okay, so I turn to the banana, but if I turn to the banana, I'll just fall to the bridge. So I have to turn to bridge. Then step distance to bridge. Right? So I need to do this. Yeah, the rat is drowned. The rat drowned. Right? Okay, this one is challenging because you need to think how to navigate. So always navigate to the bridge first, even though the banana stops somewhere around here or here. The monkey will still have to use the bridge to cross to the other side. Right? Any issues? Okay, now you're supposed to stop at 45, right? Okay. So let me see what's the next one. Okay, 46. Now, the reason why I asked you to stop at 45 is because the variables are getting more challenging, right? So for this, your variable is d equals 5, right? So by right, the monkey will move 5. But now, if I put this, the monkey will step d, right? So step 5. So he'll move from here to here. He'll get the first banana. Now he turns right. Now, what is this next variable? This next variable means I'm using the current variable I have, which is 5, right? So 5 here, this will be 5. I'll just type it out for you, easier for you to see. I cannot change, sorry. I cannot change the code. Okay, never mind. So the D here will be 5, right? So 5 equals 5 plus another 10. So what it means is you'll move 5, then after it moves 5, you'll add a 10 to it. So this is a second variable, but I'm using a variable to add on to the variable. I'm using a value to add on to the variable. So if I run this, right? So right now, if I use this code, the monkey will move 15 steps because D is 5 and plus 10, it'll overshoot and go into the river. Yes, it got a banana, but it drowned. So what you need to do is just change this and make sure your first value adds to the second value, plus the second value will make it stop here. So for here, it's 10 because D plus 5 is 10. Right? If you can see below at the table, it does the same thing. Okay. So what is the one we need help? That's what 48, right? Okay, 48 then. Okay. Okay, so 48 is the same thing. Now that I've explained 46, hopefully it's clearer, right? So this, how many times do I repeat? 1, 2, 3, 4, 5. So I'll just put 5, right? So now, next one is my first digit is, my first value is 8. So after that, it's 12. So it should be D equals D, which is my first value here, right? Plus 4. Oops, sorry. Okay, because 8 plus 4 will give me 12, right? So now this is 8 plus 4 will give me 12, and it'll keep increasing by 4 because the next number will be 12, 16, 20, 24, right? So if I run it, okay, you can see that my numbers are getting bigger. If you look at the value here, it's adding 4 every time it reaches D, it reaches increase by 4, right? So this one is difficult. Frankly, when I first did this, I also got stumped. So you need to understand that the value plus whatever value is here, and you need to put it inside a loop, which is 5 times, right? Okay, which one? 47. Okay, same thing like what I showed you earlier at 48. So if you can do 47, you can do 48, right? So what is this? What is my first number is 4. So my first value is 4. So 4, 4. And I need to increase it by 4. So 8, so 4, right? So the first one, let me see, there's the only thing I need to change. Yeah, okay. So the first one, monkey will move 4, then it will move backwards 4, then it will increase by 4 again, right? So this is how it's done. Look at the value at the bottom to show that, to see that you're doing it correctly. Okay? So what this does is to make it increase by the number I have after the plus. So if I plus 10, it will increase by 10. So every step will increase by 10. So I have 14, 24, 34, right? Okay? It's not easy to understand, but it takes time, so you need to practice. Yeah. Okay. So right now I'll move on to 51. After I've covered the arrays principle, you'll continue from 47, right? And see how far you can go. Because I only have half an hour left. Okay, let me go to 51 and I cover arrays first. Then you have a slightly better idea of what it's going to do, what you have to do later, right? So at arrays, now, what are arrays? Remember yesterday we were doing objects, everything here is an object. The monkey is an object, banana is object, the bushes are objects, okay? Now, what we are doing now today for this arrays, it's like a variable, except variables can only store one value. Arrays can store multiple values in indexes. Now, what do I mean by that? Banana is an array. The banana can also be a variable, right? But if I put banana equals 1, wait, okay. Let's say if I put banana equals 1, this is a variable, right? The equal will make it a variable. Arrays is in two brackets, in a bracket. So banana, okay, 0, as you can see, the same thing here. Banana 0 will go to the first banana, indicate a banana. So I have many bananas here. So they're all indicated by numbers. And in an array, the indexes, which are numbers, always start from 0. So let's say if I have 3 bananas, my numbers will be 0, 1, 2, not 1, 2, 3. Okay. So remember that. Try to remember this. So for bushes, you can see I have 0, 1, then 2, 3. I have like, this will indicate how many what is the number of bushes I have. Okay. And it's not a variable. Variable can only store one value. Array can store multiple values, right? But it's in an index. So this is called an index. Okay. So what you need to do here, simple. First thing you need to change, you need to turn to the banana 0, which is this one. Then you step distance to banana 0, right? Next thing once you're here, you are turning to banana 1, right? Then you need to step to banana 1. So same thing, step distance to, and click on it, banana 1. So this is banana 1. If you don't or unable to find it, just move your mouse, hover over it, and you can see the index, which is the numbers in the brackets. So if you want to turn to it, then you press that. Okay. So let's say, for example, I don't want the banana. I want to turn to bush 12. Okay. Then I want to step distance to bush 12. So what it does is this. Okay. It'll turn to bush 12 and it'll walk and it'll get blocked. Okay. So this is an example. The actual code is this: turn to banana 1 and step distance to banana 1. Okay. Now, you might encounter this later. If it says bananas, then type in bananas, not banana. If it's not accurate, if the two words don't match, the code will not work, right? So for this, if you're able to take 15 minutes, complete from 51 to 60, right? It's getting more complicated. That's why I'm giving you more time. For those who haven't completed 48, 49, 50, please do that. Please do so and then continue on with the arrays. Ken, any issues? Type in the chat. I will help you after when we come back. Right? Ken? Okay, I'll see you all in 15 minutes.
Oh, hi! Are you wondering what I'm doing? I'll show you. This is quite neat, isn't it? And I made it myself. And you can do it too with coding. What's coding? Well, have you ever wondered how computers do the things they do? Like play movies or show pictures or make music? How does it know what to do? That's what I wanted to know too. Computers know what to do because of coding. Think of it like a recipe book for when you want to make your favorite food. When the computer is turned on, it needs instructions. And when you ask it to do something, like use Netflix or YouTube or anything, it's like giving it a recipe for how to do it. But instead of ingredients and cooking, it uses something called a programming language. To us, a page of code looks like a page with numbers. But to a computer, it's in a language it can understand. And there are different computer languages in the same way that there are different human languages. We have English, and French, and German, and they have things called C++, or Python, or Java. So if you can understand English, you can follow a cooking recipe written in English. But if you don't understand French, then you won't know what to do with the French recipe. Anyone can learn to program, and some languages are easier than others. If you work hard at it, you can get a computer to do whatever you want. That's how they make video games. That's how they make computer programs like drawing software. And it's even how they make websites like YouTube and TikTok. Nowadays, almost everything uses a computer in one way or another. Can you think of how many things in your house use a computer? Smartphones and devices are little computers. TVs also have computers in them now. Even things like microwaves and calculators have teeny tiny computers on them. So how do we get all these computers to work together if they use different languages and do different things? It's kind of like human languages. All the different languages in the world might have different words and sounds, and even a different alphabet. But they all have a few things in common. They all use letters to make words, and the words go together to make sentences. And sometimes, even if we don't know exactly what someone is saying, we can understand what they mean by how they say it. It's a bit like that for computers. It's always better to speak to a computer in its own language. Speaking to it in a different language might lead to mistakes. So maybe you have your own idea for an app, or video game, or computer program, or maybe something so futuristic and advanced that only you can think of it. Well, you can make it happen. There are lots of smaller, easy computer languages to learn to help you understand the basics of coding. And once you master the basics, you can move on to more sophisticated and challenging languages to really make things take off. When you finish a program, please let me know. You can tell me about it in the comments. Also, please like this video to
Right. Hello. Welcome back. Okay. I've seen your chat and your chat. A lot of people asking for 47. So I'll go back to 47. For those who are asking where do we stop, we stop at 60 for today, if possible. Right. So I'll go to 47 first. Hmm. Okay. So 47. There's only one number for you to change. Right. So what you need to do is you need to look at the number here, which is 4. So your variable is 4. Right. So this is correct. What you need to do is now every time it moves, the turtle moves a spot, you want the monkey to increase by 4. So your variable here 4, it's already 4. The d is equals 4, it's already 4, right? So what you have here is d equals 4 plus another 4. So after that, when you run, if you look at the variable table below here, you'll see that your d, which represents 4 initially, is increasing by 4 every time the monkey moves up, right? So this is to make the monkey increase the numbers or increase the variables by itself. Then, okay, now which is the next one I'm looking at? There are some 48, so I'll go to 48 first. There'll be 50, so let me go to 48 first. Okay, 48 is the same thing. If you understand 47, then 48 is just, you have to just type it out yourself, right? So for this, my variable is d, so d equals 8. So, but I cannot type out 8. So I will type out d because I'm using the variable, right? I want the variable, which is 8, to keep increasing by the number I want it to. So for this, it's 8 plus 4 will be 12. So 4. Okay. 1, 2, 3, 4, 5. Then you change the number of times the number of bananas there are. Right? So if I run this, let me see. Okay. If I run this, okay, you can see your initial value d has just added 4 to it. Then every time it moves forward, it'll add 4. So instead of 8, it'll become 12, 16, 20, and 24. So this is what it does. This is what d equals d plus 4 does. Okay, you can d equals d plus 10. You can plus any number you want as long as it works. Or as long as it gets you to the banana, right? Okay, so 50, right? 50. Excuse me. All right. Okay, so for this, it's the same thing, except you need to do it with the turtle and the monkey, right? So for the first one, d equals 6 means the turtle is moving 6, right? Actually, you don't need to do it for the monkey, but okay. So d equals 6 means the turtle is moving 6. So for here, since they gave me a blank here, that means I need to fill in this blank. D will be equals to d plus 2 because I want the turtle to keep moving 2, increase by 2. So let me try this first. I know the code is wrong, but let me try this first anyway, right? Okay. What did I miss out? What I missed out is the turtle move, right? So then, does it move? Oh, it's moving too far. Okay. So for this, even though it's by 2, sometimes it's too big, the number is too high, so you just change it to 1. But then sometimes you'll slow down, so you need to adjust, right? Now, what did I do wrong here? The next one I did wrong is I didn't ask the monkey to step backwards. So step minus 14 because he went forward 14, right? So 1, 2, 3 times. So hopefully it's 2, sorry. Leave it at 2. Yep, too much. Okay. It's too much. So you need to change the number accordingly. Can? Right? The code is this. Total step D, so D, then D plus 2. So it should run like that. Okay, so this is the what you call it, the format of it, right? So this is number 50. So what else do you need now? The 60 plus will be for tomorrow. So I will just skip the 60 pluses. 52, 53, 54. Come on. Okay, 52. Okay, so say boo, both of them will run away, right? But the problem is the next one is steps 10, right? Only stepping to banana 1. It's not stepping to banana 2, banana 1. It's stepping to banana 0. It's not stepping to banana 1. So you need to turn to banana 1, then step distance to banana 1. Okay, so like that. So first you'll move, then you'll move, then for here, you'll turn and move, right? So this is how it's done. Can? You need to remember that if there's more than 2 or more than 1 array, you need to put the correct number. You cannot just go for one, the first banana. You must go for both. Okay. 53. Right. Okay, so for this, simple. Turn to banana 1, step distance banana 1, turn to banana 2, turn to banana 0, step distance banana 0, turn to banana 1, step distance banana 1. So it's a repeat, right? Okay, so it's a repeat, and next one will be okay, as you can see, remember what I said earlier. If there's more, if the indexes don't start at 1, it starts at 0. So now I've got 3 bananas, but my third banana is called banana 2, right? So remember that if you use arrays, the indexes always starts at 0. Okay, this is how it's done. Ken, is there a way to cut down the code? Maybe. You have to try. Okay, 50? Okay, I'll go to 50 then. I'll go back to 50. Okay, I just showed you this earlier, right? So what you need to do is ask the turtle to move first. Then you define a variable for it, right? So what you need to do is this. So turtle step D, which means the turtle will step 6, which is here, right? After that, the monkey will go forward. The monkey will go backwards. Then this, the turtle increase by 2 every time. Okay, so this is what happens. Okay, you can see that the turtle moves 2 every time the monkey comes back. Right? Ken? This one is about your formatting, or where do you put the steps first? Right? Where do you want to put what the tortoise moves, who moves first? Right? Okay. What happened? Oops, sorry. Okay, so which is next? 60, for those who are 60 onwards, we'll cover it tomorrow. Okay, anything within 60, I'll cover today. Screen is not showing. Is it showing now? Okay, I'll go back to 49 then. Okay, so 49, you need to type it out yourself, right? So my first variable will be d equals 20, so it will be the first one, right? Now, when the monkey moves forward, I want it to minus 3. So what I need to do is 1, 2, 3, 4 times dot 4. No, sorry, couldn't think. Right? Yeah. So step D. So we ask the monkey to step first. Then we ask it to turn right. Then we ask it to D minus 3. So every time it moves, the monkey will move 20. Then it'll minus 3 after it moves 20. Right? So this is what it does. Okay. So this is just a minus. This is just a minus formula. It doesn't always have to be plus, just minus. Right? This is 49. I'll help you with the 70 plus tomorrow. Right? Anything after 60 is tomorrow. Can? Anything before 60 today? 33. Okay, fine. Right. Let me go back to 33. Okay, so 33 is 3 variables. So you need to use all 3 variables, right? So there's 1, 2, 3, 4, 5. We'll use 5. So this one, I need to measure my steps. So how many steps from monkey to banana? So what I need to do is this, right? So it's not 5 steps, it's 10 steps. So my X, I need to change to 10 because it says step X. So for here, it's step 10 times, right? Now I need to check whether the degrees are correct. So I let it move to the first banana first. Okay, so the turning is fine. So I'll leave the turning alone. Let's see how many stars I get. Okay, I get 3 stars, so it's fine. I can leave the number of times as it is. If I get 2 stars, then I'll change this to 4 because that's one unnecessary turn, right? So for stepping, if it says step X, means step 10. D means the turning degrees. So if it turns 72, so it should turn 72 here. So I run again. Okay, so this is how you do it. This is good. Right, okay. I got 50, 49, 53. Okay, I'll finish this two for you. Okay. For those who are done, please practice what you have, then we'll continue tomorrow. Right? 49 and 53. Give me a minute. And please remember what we learned today. What we learned today is variables and arrays, right? And remember, a variable can only store one value at a time. Arrays can store multiple values in an index. An index is like your list. It's like a number list for you to hold the numbers, for you to check your numbers, right? And always the indexes will start at 0. Okay, so for 49, this is how you do it. Basically, you're just asking the monkey to move forward. After that, moves just minus the value from 20 to 17 is 3, so minus 3, and then ask it to keep removing 3 every time it moves. Right? So for 49, it's this one. Can? So it'll move like that. As you can see from the table below here, the value will keep lowering by 3. Right? Okay, so 50 is the next one. This will be the last one I covered today. Right? Again, this is how you do it. Excuse me. Okay, ask the turtle to move. the monkey can just move forward and backwards, step 14 and step minus 14, right? The most important thing is to control the turtle. So the turtle will move forward, he'll move 6. After that, he'll move 2 because D, if you see here, D equals 6. So this is 6. This will be 6 plus 2. So 6 plus 2 will be 8. So every time it goes forward, it will be 8 plus 2. The number will increase and the number will stay there. Right? So this is how it looks. Okay. Okay, for those who are unsure what, not very clear on what to do, or still having issues, keep practicing, right? Practicing, and once you practice, it's easier for you, right? Okay, I'll go to 55 then. Okay, so these are beavers. So you need to control the beavers. Again, the beavers are arrays, right? So you can see beaver 0 and beaver 1. So for the first one, it says beaver 0 step 10. So the beaver should move 10, right? The next one, you need to ask beaver 1 to move. So it's the same thing. It's just a repeat of this, except you click beaver 1. Oh, sorry, wrong one. Okay. Except you make beaver 1 move and step 10, right? So after beaver 0 moves, beaver 1 will move, and that's it. Can? Right? So you have to ask them to move in turns. Whoever you want to move first must move. Must move first, right? So again, you need to ask yourself the question, which one to move first. Can? Okay. Right. So I'll see you all tomorrow. Wait, there's a 53. Okay, I'll finish 51 and 53 with you. Okay, for those okay, for those who are leaving, yeah, I'll see you tomorrow. So for those who are still asking for help for 51 and 3, please wait. Okay, now again, this is basically asking the monkey to turn to the correct banana. So right now I already turned to banana 1. So by right, the monkey will go to banana 0 and then he'll turn to banana 1. So the monkey will stop here. So I need to ask the monkey to step to the banana, right? So it's basically a copy of this, except banana 1. So step distance to banana 1, right? Because you're already facing it, so you need to step to it, right? So next one will be 53. After that, that's it for today. Wait. Then please go and try on your own. If you have any issues tomorrow, let me know. Type in the chat, let me know so that I can assist you, right? Now, for this one, it's simple. You just need to make the monkey move from one banana to another banana and the third banana, right? So same thing, it's just a duplicate of this, just a repeat of this. You can actually use repeat, but they don't let you use it here. So just use turn to the next banana. So you already turned to the first one, which is taken here, and the monkey walk up to it. Next one is banana 1, right? So once you turn to it, you face it, you need to step to it. So step distance to banana 1, right? So for the next one, it's banana number 2. So next line, I need to turn to banana number 2, and then I need to step distance to banana number 2. Okay. Can? Okay. Any other issues? Let me know. I'll solve it for you tomorrow. I'll walk through tomorrow, right? Okay. I'll see you tomorrow. Thank you and enjoy yourself.
Many parents ask us, do I look for coding or robotics program for my child? What is the difference between them? Now our answer to that is very simple. These two are actually the same, under the umbrella of Computer Science and ICT. Hi everyone, my name is Jonathan Ho. I'm the founder and CEO of Graphite Academy, and we are a coding school for kids. So we started the company because we realized there was a disconnect with what the parents wanted versus what the industry was providing.
Hi, my name is Rena. I'm the co-founder and CEO of Graphite Academy. At Graphite Academy, our mission is to provide students with quality coding education to prepare them for their tertiary education in computer science. Learning from us should provide students with a head start in their computer science education.
To date, Graphite Academy has taught over 120 schools in Singapore, both primary and secondary school, on the topic of coding, programming and robotics. And because of that, we have impacted over 10,000 students in Singapore. What a coding school does is we introduce students to many concepts that are very relevant to our daily lives. Things such as app development, web development, robotics, hardware, AI, AR and VR are all prevalent in our daily lives, but most of us don't know how these things work, how these things function.
Coding is a compulsory enrichment subject in MOE schools starting from primary 4. This is important when students move on to tertiary education, as it is a mandatory module for many diploma and degree programs.
Our students also learn skills such as problem solving, critical thinking, and even learn how to appreciate the mathematics they've learned in school and apply them in real and relevant concepts.
My intention is just to give him the exposure, and if possible, if he really likes it, is to support him all the way until P6.
Our students have also won awards from competitions such as First Lego League, National Primary Games Creation Competition, National Robotics Competition, and many other competitions as well. And the most recent one was the Coding Olympics 2022, in which we organised it with Science Centre, and our student actually achieved second place out of 800 students in the entire Singapore. We are also a member of the Computer Science Teachers Association of Singapore, which is actually recognised by multiple industry tech titans. Companies like Facebook, Microsoft, Google, Amazon, even Rolls-Royce recognize this as the gold standard of children's education for computer science.
Flying Cape is Singapore's largest online booking and advisory platform for tuition and enrichment classes for children. On the platform, parents can first discover your child's strengths, interests, and learning profiles through validated assessments that we offer. For children 6 to 12 years old, our gamified assessment allows your child to try out a series of challenges while navigating through 8 different islands, each representing a different intelligence. While your child is having fun, parents receive a diagnostic report that provides insights into their unique competencies and learning styles. Based on your child's unique learning profiles, we offer personalized recommendations that help parents customize the best education programs and classes. We also have a best price guarantee promise to ensure that you will always get the best prices with us. Choose from the widest range of education options on the platform, such as trial classes, workshops, holiday programs, learning kits, and more. Earn reward points when you make a booking through us and redeem vouchers and gifts. Always on the lookout for the best education deal? Join our group buy under Edu Hunt, which allows you to snag the best savings on workshops or classes that you're interested in. Simply place a reservation for the class that you are interested in and help spread the word during the time sale period. The more people joining in, the greater the price savings for everyone. Join our community of happy learners now. Check us out at www.flyingcape.com.sg.
Is your child ready to take their coding skills to the next level? Introducing Elite Coder, the groundbreaking certification program brought to you by Singapore Science Centre Global and Mangosteams in partnership with Flying Cape. The program is designed to map a student's mastery of coding at 3 different levels: basic, intermediate, and advanced. Here's why your child should sign up. Elite Coder enhances their coding portfolio, giving them a distinct advantage. Elite Coder evaluates your child's competencies based on the CSTA K-12 Computer Science Standards. Upon completing each assessment level, students will receive a scorecard indicating their level of proficiency. They will also receive an e-certification by Singapore Science Centre Global, recognizing their achievement. But how do students prepare for the assessment? Our authorized training partners will ensure that students receive the best guidance. In the training workshops, our experienced trainers will cover Elite Coder requirements and expectations at each level. They will deep dive into the syllabus and guide students through code writing lessons aiming at solving real-world challenges. So, what are you waiting for? Give your child the opportunity to excel in coding. Find out more at elitecoder.flyingcape.com.sg.
Probably heard about this thing called AI. It's everywhere now. But what exactly is AI? It's our new friend. Hello, Owl.
Hiya, Monkey. Great somersault.
Thanks. Say, I was just telling my friends about AI.
You mean artificial intelligence? That's when a computer learns like you or me.
We use it when we're trying to do amazing things, like pulling off the best somersaults of all time.
That's right. The AI we're using at the moment is for pose detection.
That's right. When we program things, we're telling the computer how to do simple things, like climbing a tree.
But if you want to do something really complicated, then we need help from a computer that can learn.
AI helps us do really amazing things, like shopping assistance, organizing data, training employees, and even household chores. You can try out the same AI course on the CodeMonkey website and see for yourself how the computer teaches itself.
The computer learns by doing puzzles, just like us.
But that also means that, just like us, AI can sometimes make mistakes. Whoa! I think our AI has a bit more studying to do.
Good thing I know where we can do that. On the CodeMonkey website, where there's a game to learn about AI.
Great idea! We'll practice there! But next time...